Hey guys, I wanted to come on and review with you for your common assessment that you'll take this week. This is the first common assessment. It will cover everything from our first unit on states of matter to the periodic table and atoms. So I wanted to start here on my website so you can see this is where you can go to review everything you've learned so far. So it's Tyson, TISON, PCHS.weebly.com. You come to physical science course units and we have covered unit 1 and unit 2. So if you review those, that's a good place to start. So today what I'm going to do is I'm just going to review a couple of the topics that I really want to be sure we hit home on. So first is a picture of solids, liquids, and gases. You see solids right here have very fixed shape. They're rigid, meaning they have a very tight structure. They have a definite volume and a definite shape. We can't squash them. We can't compress them. Okay, so you need to know that this represents a solid, this picture represents a liquid, and this picture represents a gas. All right, so if we are looking at things like water, okay, we know there's only a few differences between liquid water and solid water. Their particle size is exactly the same. So what's the only difference between this liquid water and ice? The only difference is that ice has a rigid structure. The particles are still the same size, but here there is a rigid structure. They're very fixed together. And the last thing I wanted to talk to you about on that topic is okay, why does heat and energy transfer best through solids and liquids rather than gases? Well, you can notice energy for things to be transferred, you have to be close together. So these particles are close together. They can transfer energy. Gases don't transfer energy very well because they are not close together. All right, now I want to talk to a few of you that may not have been in class about the popsicle stick. Remember P, T, and V, pressure, temperature, and volume. What you would do here is cover up what you're not using. So if we're looking at pressure and volume, we cover up temperature. If we're using a temperature and volume, we cover up pressure. So for example, if we take a container, a vessel, and it's at room temperature and pressure, okay, and the volume can't expand or contract, so this is not going to change. We hold our finger here, and we know that if temperature goes up, pressure is also going to go up. Because imagine you're holding your hand here, and as you pull temperature up, pressure is going to go up as well. Another thing, let's imagine that we compress it. What's going to happen to pressure as we compress it? So remember, don't say anything about temperature. So we put our hand over temperature. As we compress it, volume is going to go down and pressure is going to go up. So just remember, volume and pressure do opposite things. All right. Now let's look at a phase change diagram. Remember this? We start at low temperature, low energy. And here, once we go up, we have high temperature, high energy. So on these flat lines, you have your phase change happening. So we're heating it up, heating it up, heating up, and then we reach our melting point. And it takes a little while. We have to sit here at the same temperature until the whole thing melts. And then we heat it up, heat it up, heat it up. And then we sit here while all the particles boil. And then we heat it up. So the temperature is not changing on the flat lines. Notice this is temperature. So if the line is flat, temperature is not increasing. So what is increasing is heat energy. So your energy is increasing all the way up, but temperature is not. So as you go this way, be sure you remember, temperature is going to be increasing all the way up. I'm sorry, heat energy will be increasing, not temperature. So look at your line. Heat energy is being added the whole time. We're always having that pot on the stove. The heat energy is always being added, but your temperature doesn't change on these flat lines. All right. Also, on this flat line, there is this plateau, and we want to know what is happening here. Why is the line flat? The line is flat because temperature is not changing, because the heat is actually increasing the potential energy of the particles, making those particles have more potential energy instead of the kinetic energy. So here, as we increase temperature, our kinetic energy is increasing, but when we're on these flat lines, potential energy is increasing. It's not, the temperature is not moving. All right, so let's look at now a picture of the atom. We have positive protons We have negative electrons on the outside in the electron cloud, and we have neutrons that are neutral. All right, so we want to look at if this whole atom had a -2 charge. Right now we have a neutral charge because we have 1, 2, 3, 4, 5, 6 protons and 1, 2, 3, 4, 5, 6 electrons. If positive and negative is equal, it is neutral. Let's say we had a -2 charge. That would mean we would have to have more negative than positive. That would mean if it's -2, we'd have 2 more electrons than we do protons. Okay? That's if we had a -2 charge. All right, so we want to know what two things are in the middle. Those are the protons and the neutrons. And remember, we said there's one thing that can never change. Protons can never change because this is your atomic number. So if you change your atomic number, you change the element. So protons will never change. But there is one thing we can change here in the nucleus that will affect the mass, and that is your neutrons. So if we want to change something that's going to affect the mass of our atom, we would change the neutrons. Okay? Heat and energy, we already talked about that. Lastly, I want to look at the periodic table. Okay, so we've got some charges here on the periodic table. You'll see them up at the top. Now, we have metals to the left of the stair step, and you'll see right here they are a solid. We have our gases and liquids over here. Now, you'll notice there's a liquid metal. Mercury is the only liquid metal. Remember, if we want to know how many valence electrons something has, we look at its group number. So if everything in group 1 has 1 valence electron, everything in group 2 has 2 valence electrons. Skip all of these. Everything in group 13 has 3 valence electrons, 14 has 4, 15 has 5, 16 has 6 valence electrons. Remember, valence electrons are in the outside shell. 17 has 7 valence electrons, and 18 has 8. 18 is full. They have a 0 charge. They don't bond with anything. They don't react because they have a full outer shell of electrons. So, if we look at which elements are going to have the same valence electrons, they're going to be the elements in the same group. Elements in the same group will have the same number of valence electrons. If we wanted to know which ones could conduct electricity, remember you need metals to conduct electricity. So if we want to know which ones could conduct electricity, it would be anything that included a metal. So if you saw a compound with sodium, magnesium, potassium, any compound that has a metal in it can conduct electricity. Anything that has 2 nonmetals, not going to conduct electricity. It has to have a metal. Okay? So another thing is about the charges. You're going to be asked which ions would form based on the periodic table. So this group will always form a -1 ion. F will always form a -1 ion. Chlorine, -1. Bromine, -1. Iodine, -1. Hydrogen over here, lithium, sodium, potassium, they're always going to form a +1 ion. Aluminum, always going to form a +3 ion. So just be sure when you are asked to determine which ion they would form, look at the charges on the top of the periodic table. Okay, so look at the charges on the top of the periodic table. Lastly, lithium and sodium, right here. Lithium and sodium, they're both in the same group. That means they both have what in their valence shell? They have 1 valence electron because they're in group 1. Lastly, the noble gases, remember these guys over here. They have 8 valence electrons. They are all non-reactive. They do not react with anything else. They are full. So they will not form ions. They will not form ions. There will be a 0 ion there. Okay, so that's just a short, quick review for you about the common assessment that we'll be having. Be sure you watch this several times, and I think you'll be perfect, and review the website.